Okay, so thank you very much, Ilya, for organizing this convention and inviting us. So I spent the first decade of my career in Bar Ilan at the great lab of Professor Chaim Cohen. And I would like to tell you a little bit about what we are doing at Centarix today. After my postdoc, I was fortunate to join Shimon Meshi and Yitzhak Dershowitz, who are here as the co-founder of the company and CTO. I really hoped after my postdoc that there will be a place, to work in this field, outside of the academy, to push what we are doing in the academy, also the industry, and there was some luck here. Okay, so I will explain a little bit about the company. So we are a privately held company. We were founded in 2018. We develop innovative technologies in longevity. We operate from a state-of-the-art facility in Jerusalem, and we employ over 70 scientists, diverse, from scientific and health disciplines. Now, our main projects are, the first one is about cellular rejuvenation. What we are doing here is taking the epigenetic rejuvenation approach. For the last 6 years, we have been trying to isolate a cocktail of epigenetic modifiers that can rejuvenate the cell, mainly by the epigenetic clock, but also transcriptomics. And I'm happy to say that we have a few patents about these cocktails that can reverse the age of the cells epigenetically by a few decades. At least I think officially, I don't know of any better methods. And also the approach that we are taking is safer than what was published until now. Now, in order to have some validation of our success in the cellular rejuvenation project, meaning we're taking cells from old people and trying to rejuvenate them, we need to be able to measure the molecular hallmarks of aging. So we did work on that also and develop wet processes technologies, improve current technologies in order to be able to measure those molecular biomarkers at a larger scale, at a lower cost. And so this is kind of relates to the other department of our company, which is aging diagnostics. So it started as a department that supports the cellular rejuvenation team, but then, we thought about it, there is a much greater need in aging diagnostics than only to support our other department. And what I'm talking about is the situation today at 2024 that we have. This is just a small example of anti-aging treatments that work in rodents. All of them were shown in peer-reviewed papers to extend lifespan, delay aging diseases. But the thing is, okay, we have many candidates, and every year we have more candidates. The question is, when will this work in humans? Like my grandfather asked me 10 years ago, Noam, when is what you are doing will help me in my lifetime? And I told him, yeah, Grandpa, I hope so. But he died, now, a few years ago. And to tell the truth, even if he was living today, with the current approach, there was nothing to give him. And it's a decade of practically zero progress in what we can give people. And the big problem here is not about, in my opinion, it's not about methodologies to rejuvenate, about interventions. We have interventions. Of course, we can form better interventions, but we already have many candidates. The question is, how do we validate in human? So the road to practical validation. So the gold standard of validating what we are doing in rodents, because they live short, we are checking whether the intervention increased lifespan or whether we see a delayed onset of aging diseases. Now, the good thing here is a reliable endpoint. But the bad thing when we are discussing human, of course, is that this is very slow. We are talking about decades of waiting. It's very expensive because it's so long. Maybe we can reduce it, to a decade if we are following onset of aging diseases in a very large cohort, but even a decade. And moreover, it's not personalized. So let's say that we did such an experiment for a decade or two, and we found an intervention in humans that can reduce the amount of cancer and dementia by 5%, 10%, something along those lines. And now I, Noam, want to take this treatment. And the thing is, I will take it, and I need to pray every day that a few decades from now, it will help me. How can I know if it helped me? I mean, the fact that there is a cohort that got some, average, statistical significant advantage of this intervention doesn't say that it will work for me. For any drug, it works for 50%, 60%, 70%, and the rest it doesn't work, and there are people that it will even make them worse. So I need to pray that it will work. I need to wait now a decade or two and get maybe a treatment that will maybe extend my life 10%, and I need to pray every day that it works. So we think this is a problem, this is a huge bottleneck. Now if we go to the other extreme, how do we validate those interventions? I think there is a lot of debate here. The other way around is going into a single biomarker of aging, like the other edge. And here we might talk about the epigenetic clock, which is, very popular recently, and for good reasons. There are many papers, connecting it to biological age. So, and we are talking about a fast and cheap modality. It correlates with aging, this biomarker, and it's a personal result, meaning I can know with my body relatively early if the treatment is changing the epigenetic clock in a favorable manner or not. The problem is it's very limited reliability. How can you be sure you are optimizing the right stuff? Maybe you are making the epigenetic clock better, but the rest of the body is becoming worse. We don't know. I think there is some paper that claim that alcohol consumption to some level rejuvenate the epigenetic clock or correlates with lower epigenetic clock. So there are a lot of confusion about how much can you trust these biomarkers. And the last approach that I want to say, this is the approach that we took, Centarix, is we can call it a multimodal aging biomarker panel. What we are doing here, we are working with biomarkers, but in a very robust way. So we are taking biomarkers, molecular biomarkers, such as the epigenetic clock, but not only. We are using clinical serum analytes markers for a very robust panel to see the health of the organs clinically. We are taking a functional biomarker panel, meaning all of the functions that deteriorate with age, whether it's aerobics, muscle power, flexibility, balance, etc. And we are also doing imaging to understand the body composition, how the organs look. So we are taking all of this big panel from micro to macro, and we are using it to assess health and biological age. And the advantages here, it's still practical. Yes, not as practical as the epigenetic clock alone, but it's still practical. It's very personalized, and it's reliable for judging health. Now, you might ask, okay, let's say that I'm taking an intervention, and I'm using this multimodal approach, and I'm seeing a favorable profile. Yeah, a lot of stuff are improving, and I don't see toxicity or side effects. Does it mean for sure that it will also mean that I will get more lifespan and there will be like a delayed onset of aging diseases? I don't know. We don't know. I hope so. It seems logical. Yes, that if I'm getting healthier, then it will extend my lifespan. We can be sure, but I will say something which might be blasphemy here. Maybe we don't care. Maybe we shouldn't care, because the question is, what are we after? Are we after improved health, more healthy years, or are we after living longer, just living longer? So if I have a panel, a robust panel, a reliable panel for health, and I see that an intervention that worked in mice to extend lifespan, I see that for me, it brings a lot of health benefits with minimal or no side effects. For me, it's good. I want to be healthier. I want to be healthier now. I want to be healthier in a decade. And if an intervention gives me that, according to this reliable multimodal approach, I'm good with that. Now, maybe I will not live longer. Maybe I will die very healthy, but not very, at very old age. I'm okay with that. Okay, now the problem here, let's say the difficulties here are standardizing such a panel. Like, okay, which test are you going to select? You need to be very smart here. And which machines, which protocols. You need to be very careful how you are going to measure those biomarkers and also calibrate. You need to calibrate it in the population. You need to understand what happens to those biomarkers in the open. You know, when people living their lives without treatment, what is the noise, what is the signal? So there's a lot of work that needs to be done here. And we have started doing this work a few years ago. We have started a clinical trial in 2021 under the Helsinki of Hadassah Mount Scopus. And in this clinical trial, so it's a longitudinal multi-year study with hundreds of participants, aged 20 to 80, only healthy people. It was very important for us to make this, to check those biomarkers on people when their health is mainly affected by chronological age and not because they are obese and not because they are now with a great sickness and taking medicine, because again, the cohort is not big, so we don't want this noise. And here, regarding the endpoints, we carefully selected a large diverse panel of multimodal aging biomarkers. We did a measurement at short intervals, so half a year intervals. And all the biomarkers are measured in-house, so they came to us. Some of the biomarkers, the molecular, again, are development that we did. And we also generated a very large biobank of multiple cell types from each time point. And this allows us now, if we want to check a wet biomarker, we can simply unfreeze the samples and see if we see a signal with age. And now, it doesn't move. What happened? And now the big study goal here is to building a biological age ruler. And the important questions in order to do that are, first of all, how detectable are the aging trends that we are going to see for each biomarkers? Understanding the biological noise. So again, we might see that, in the wild, without treatments, we see that telomeres are extended after 6 months or a year. And we need to understand by how much. It's a natural phenomenon of the human body. And the same question for each biomarker. How does it behave? How can we differentiate between noise and signal? Behavior of wet biomarkers, those that you are checking on cells, on different cell types. So people usually use whole blood for such experiments, but we used subpopulation also because we don't know what happens in T cells, in monocytes, etc., neutrophils, what happens in buccal epithelial, all of the cells that we can easily collect from the body. We want to understand specifically what happens there. Maybe it's different than looking at whole blood. We want to understand correlation between different biomarkers and also develop algorithms from composite biomarkers. And here I'm showing you some results, some portion of the results that we got from the test. So what we are seeing here, you are seeing the population of the study, even not all of them. You see the population, the x-axis is the age from 20 to 80, and the y-axis is the biomarker. And what you can see here is a very clear trend, whether it's visceral fat, balance, working memory, visual memory, a lot of cognitive skills, systolic pressure, CPET. And the interesting thing here, it's a relatively small cohort, very diverse ethnicity, different lifestyle, and we see the aging phenotype so clearly. And we have dozens and dozens and dozens of such graphs of biomarkers. And what we are seeing here, so again, we are measuring from the molecular to the serum to the functional to the imaging. And what we are seeing actually is the phenotypes of a disease called aging. These are phenotypes of a disease. And now the question is, can we take the treatment? Can we give somebody a treatment and then follow those biomarkers as endpoints? I mean, if we know that there is a decline, and if we see that the intervention is improving the decline, okay, yes, is reversing the decline on many criteria in this panel, maybe we should use that, because this is practical, this is now, this will yield results relatively fast. Yeah, it's very important, to have this ability to measure quickly. Okay, so based on this clinical trial, we have recently opened a clinic that does this commercially at Jerusalem. And in this clinic, we are doing this multimodal approach. And now I will shamelessly advertise us a little bit. So basically, we are offering biological age measurements at scale. In terms of businesses, we are offering also remote longevity testing because, as I said, we developed biomarkers of aging that you can check on all sorts of cells. And also, we want our clinic that does the multimodal approach to be a site of clinical trials. Like if somebody has some kind of a treatments, supplements, or whatever, things that might work in human to delay aging, we want to be a site for this and check it in our physical site. And regarding customers, we have started servicing customers as an advanced longevity clinic. I think the most advanced in the world, where you are taking the multimodal approach measurement, and then we are working with you, with a team of professionals, to rejuvenate those biomarkers, because those biomarkers are very robust from the molecular to the imaging. And thank you very much.
And can you go to accelerate aging? Can you know also how to accelerate aging?
Yeah, I think it's very easy. We can accelerate your aging very fast in 6 months. Just let me give you a recipe and follow it closely. It will involve drinking a lot of alcohol, not sleeping well, I don't know, a lot of stress, smoking, maybe a war, maybe a small war with surrounding countries. Yeah, it's very...
Because it can help in your experiments. I mean, it's not so ethical, but it can help in the experiments.
The other side, you mean?
To move people on both directions.
Hi, Noam. As part of the cohort, I was surprised that you don't take the microbiome, which is generally blamed for everything, including aging.
You're talking about the?
Microbiome.
Microbiome. Yeah, so the question is why aren't we, because she's a participant, we have a few participants of our clinical trial here, why aren't we taking the microbiome? And it's a question about, you can think about it, you know, when we use imaging, why are we using this and not that? And in the molecular, why are we checking this and not that? The question, the thing is that there are a few modalities. There are the molecular, the serum, the functional, and the imaging. And we want a good representation in each modality. Now, we can't take everything. You cannot take everything. But what we know, all of those biomarkers are very interconnected. There is a lot of crosstalk between all of the molecular. So, for example, if you are, you know, remember the paper of Lopez-Otin, the last one of the 12 hallmarks. So you have like the primary, and then the integrative. Okay, so, and the microbiome is at the top. It's affected, but all of the molecular biomarkers below it. And we are measuring some of it below, some in the middle, inflammation. We think we are covering it enough. We are covering the molecular enough, the blood serum enough, the functional enough, very thoroughly, and also the imaging. So you are getting a very robust image of your health. And if there is an intervention that improves biological age, and we are not seeing it in such a, you know, a robust multimodal panel, I'm sorry, it's not there. It's not there. You don't have, you haven't improved health in any meaningful way. Even if you improved it in a significant way in a biomarker that we don't measure, we should have seen the side effects in all of the rest.
Yeah, I understand. So you have selected enough biomarkers to have a complete image.
Exactly.
Another question maybe, will it be for rich people only, this kind of clinics?
So sadly, it's not cheap. It's not cheap, but at the setup of a clinical trial, it will be cheaper. But again, what we are doing here, again, everything is not cheap initially. If you talk about, you know, the cell phones of 30 years ago, it was huge boxes, it didn't work well, it cost a lot. So yes, this is an early thing. We think there is a lot of potential here. We think like this is the way to go. If we want results, like we don't want to meet here 10 years ago. I really hope that you will make a convention 10 years ago. All of us will be here, and we will see not only 25 interventions in mice, like I showed you, but 2,000. And in humans, nothing. We don't want this. Yeah.
All the industry of well-being is subjective. You know probably studies about happiness, about emotional well-being, and probably it's like a killer app. Let's say a person drinking, smoking, but he's happy.
Mm-hmm.
But he's living well. He's doing whatever he likes and he feels okay with this. And he lives longer. This is something which is not going into all this data information, and nobody takes it in consideration because the influence of a person on himself is the highest placebo. So this is something which I think you should intervene in your
Okay, so first of all, we are taking this into account. What I haven't showed, like in this multimodal, it's also many questionnaires that are, you know, we have a psychologist working with us, so we are probing the human, you know, psyche. The thing is that even if you are stressed, even if you are, you know, there is the duality theory that we have a soul and we have a body and they are connected through some Bluetooth or whatever. So, you know, the mind affects...
It's even more complicated.
Yeah. The minds affect the body. Like if you are stressed, we want to see cortisol level up. We want to see inflammation. We want to see visceral fat. So it's, if you are stressed and we are checking your entire body with this multimodal approach, everything is perfect. I'm sorry, you are fine.
Yeah, but you know, I go to my father, he's 86, and he's going to the doctors and he said, listen, I don't feel well. And they check his data in 86, and they said, listen, you are compared to the average people in your age, you are perfectly, I wish I would be in your position. Mm-hmm. And this is, what kind of doctor is this? What kind of medicine is this that is not able to analyze my situation based on my specific data, but on an average? You know, you compare to the average. On the average, he's healthy, but from his perspective and the way he lives today, he feels sick. He feels that he's tired, doesn't have enough energy. And there is a solution for him, I'm sure, but not in the conventional medicine.
I'm not sure if you are saying he's 80-something and he's healthy. According to his age cohort, 80-something is not 86. Healthy. He's very, very sick. Even if you have no disease, like no conventional disease, at 80-something, you are very, very sick. If a person aged 20 will wake up someday, once he's 20, and he's waking up as an 80-year-old guy, he will be hospitalized with a deadly something that he caught. It's not, and I will tell you something that, I'm not talking about 80-something, like we got like hundreds of people with this multimodal approach. Almost everybody has many problems. They don't have a clue. They don't have a clue. Once you are taking like the biological age and looking at it as a very large puzzle, and you are showing the person everything, people are shocked what they find. Like how much they are deteriorated in stuff they never even thought to measure. So the first step is to measure, and then you see how much, even at age 40 and 50, you are deteriorated in some stuff.
Yeah, but the blood test they do, conventional medicine, is not even close to understand.
It's not, yeah, what we are doing now is much more than conventional medicine, and I hope one day conventional medicine will meet us. Until then, it will be private.
Yes, okay, thank you.
Hi. Did you check the nutrition of your participant and how it's affect on the results?
So we check nutrition in questionnaires. We check nutrition with questionnaires, and we have like a lot of blood tests that are, you know, related to nutrition. Also, you know, we are doing DEXA scans for body composition. So we have some knowledge about the, you know, what you eat and how you look and how you know, function. But this is something that is improved. So, for example, now at the most updated version of what we are doing, we are using, for example, CGMs, which give us more understanding of, for example, of the glucose, what you eat, how it affects your glucose level. So, again, we are incorporating new stuff along the lines, and with nutrition, we are taking this into account. Yeah. Okay, thank you very much.